Within the Orion constellation, there is a remarkable star that has captivated astronomers for a long time. This enormous red star is vastly larger and more massive than our Sun. Recently, Betelgeuse has exhibited unusual behavior, shrinking significantly and even pulsating violently. This has sparked theories that this once glorious star might be on the brink of a massive explosion. However, could we be witnessing the beginning of an even more intricate and troubling event? What if Betelgeuse doesn't explode but instead collapses under its own weight? Join us as we delve into the latest studies on Betelgeuse and explore its potential repercussions for our planet. In this investigation, we aim to better understand the profound effects that Betelgeuse's demise could have on the universe's future. The mysterious nature of Betelgeuse, a colossal star many times larger than our Sun, is one of the most fascinating subjects in astronomy. However, such immense size comes with a cost. Stars like Betelgeuse lead short lives, and Betelgeuse is no exception. It is a ticking time bomb, primed to detonate, though the exact moment of its explosion remains unclear. Positioned about 650 light-years away from Earth, Betelgeuse has astounded scientists by becoming one of the brightest stars in our neighborhood. We marvel at its brilliance, trying to uncover the secrets hidden within its fiery core. Yet, only around 13.3% of its radiant energy is visible to us. If we could see it in its full glory, it would shine brighter than Sirius in the night sky. Imagine a massive star, roughly the size of our Sun, extending beyond the asteroid belt and nearly reaching Jupiter. In this vast space, Earth, Mars, Mercury, and Venus would all be overwhelmed by Betelgeuse's immense gravitational pull. But the surprises don't end there. Every few centuries, Betelgeuse sheds a mass equal to that of our Sun, ejecting its outer layers in a dazzling burst of grandeur. A cloud, often larger than the star itself, surrounds Betelgeuse, enveloping it in a mist that sparks our curiosity. This cloud, stretching up to 30 light-years, invites us into a magnificent cosmic spectacle, urging us to discover its mysteries. To understand this star more deeply, we must examine the core of Betelgeuse, where hydrogen undergoes nuclear fusion to form helium in a colossal reaction. Over time, the star's hydrogen supply diminishes, causing dramatic changes as helium fuses with carbon, producing light that travels across space. However, even this brilliant fusion process has limits. When neon begins fusing with iron, a pivotal transformation takes place. The star's gravity, weakened by its loss of energy, initiates an inevitable collapse, pushing Betelgeuse toward a fate that is both awe-inspiring and tragic, a colossal explosion. Betelgeuse's journey has been mesmerizing, evolving from the vibrant blues of its youth to the fiery reds of its maturity. In the 2nd century BC, Chinese astronomers recorded an extraordinary celestial event, noting Betelgeuse's distinct yellow hue, which set it apart from the surrounding stars. Through the centuries, the task of observing this star passed to Greek and Roman astronomers. For example, the astronomer Timo, in the 2nd century AD, recorded Betelgeuse's reddish or orange hue, a characteristic that still captures our imagination today. This enduring color, observed across various ancient cultures, only adds to the allure of Betelgeuse. But then, in 2019, Betelgeuse's story took a surprising turn when it suddenly began to dim. Initially, scientists speculated that a massive dust storm had obscured our view, but the cause of this cloud remains unclear. Some researchers have proposed that an enormous object, perhaps a planet, might have disturbed the star's surface or even been engulfed by it. Recently, Betelgeuse has become twice as bright as it used to be, which is remarkable because stars usually dim as they age. Researchers are uncertain about the cause of this sudden increase in brightness, but they acknowledge that stellar luminosity can fluctuate for a variety of reasons. For example, some stars go through cycles of brightening and dimming. Betelgeuse is classified as a variable star because its brightness regularly changes, expanding and contracting, altering the amount of light it emits. This phenomenon is common in many stars, including Aldebaran and about 30 other stars visible to the naked eye. An ongoing explosion within Betelgeuse's core has been expelling stellar material into space, creating an enormous dust cloud. This dust veil blocked much of Betelgeuse's radiant light, transforming it from a brilliant beacon to a much dimmer star in the night sky. Betelgeuse's brightness dropped to levels previously unimagined, moving from being one of the 10 brightest stars to below the 20th in rank. In the months that followed, Betelgeuse's unpredictable behavior left astrophysicists baffled, challenging conventional theories about stellar dynamics. Speculations abounded, seeking to explain Betelgeuse's erratic behavior. Some suggested enormous sunspots or dust clouds were to blame for its fluctuating brightness, while others explored the idea of recurring patterns. Some studies even raised the unsettling possibility that Betelgeuse's supernova may have already occurred. Yes, you read that correctly. While earlier predictions suggested that Betelgeuse's massive explosion would be centuries away, recent evidence now hints at a different reality. The consequences of a supernova explosion would be enormous. The last significant cosmic explosion in our vicinity, the Kepler supernova, lit up the sky many years ago. Researchers have proposed models indicating that Betelgeuse is in the final stages of carbon burning, suggesting it could be nearing its explosive end. This makes Betelgeuse a prime candidate for the next stellar explosion in our Milky Way galaxy. Like the grand finale of a cosmic symphony, Betelgeuse remains a strong contender for the next monumental explosion in our galaxy. However, investigating Betelgeuse is like trying to solve a puzzle with conflicting pieces. There are signs of material expulsion and potential recovery, indicating a mass loss event, but on a smaller scale compared to our Sun. Observational challenges and the unpredictable nature of stellar explosions make the task of predicting Betelgeuse's fate even more difficult. A major hurdle is the current inability to observe Betelgeuse with pinpoint accuracy. Researchers have studied Betelgeuse for years, noting its fluctuating brightness and the possibility that it could soon go supernova. But the precise timing of this event remains elusive due to insufficient data. A massive explosion would not pose any threat to life on Earth and would be completely safe to observe from our planet with the naked eye. To comprehend Betelgeuse's role in cosmic evolution, we must recognize its crucial place in the life cycle of stars in our galaxy. Its evolution offers a glimpse into the fate of other massive stars, providing key insights into the final stages of stellar life and the impact of supernovae on the galactic environment. To fully grasp Betelgeuse's significance, we must examine its stellar structure, life cycle, and the broader consequences of its potential explosion. Classified as a red supergiant, Betelgeuse is in the later stages of stellar development. Unlike smaller stars, which burn their hydrogen more slowly and enter a red giant phase, massive stars like Betelgeuse burn their fuel much faster. This rapid consumption causes the star to expand, eventually becoming a supergiant. Betelgeuse's core consists mainly of helium and heavier elements like carbon and oxygen. As the hydrogen in its core runs out, fusion reactions begin in the outer layers, causing the star to expand. This process is driven by the delicate balance between gravitational forces and radiation pressure, ultimately leading to the star's supergiant phase. Betelgeuse's core fusion continues to sustain its enormous size and brightness. Initially, hydrogen fuses into helium, releasing vast amounts of energy. As hydrogen is depleted, the core contracts under gravity, causing temperature and pressure to rise. This allows helium to fuse into heavier elements like carbon and oxygen. During this phase, Betelgeuse's outer layers expand significantly, contributing to its immense size and characteristic red color. In supergiants like Betelgeuse, this process is further complicated by the star's massive size. The core undergoes multiple fusion phases, creating concentric shells where various elements fuse. Each fusion stage alters the core's composition and energy output, affecting the star's dynamic behavior and eventual instability. When Betelgeuse depletes its nuclear fuel, it will no longer have enough energy to counteract the gravitational pull of its own mass. This results in a dramatic collapse of the core, leading to a supernova explosion. The supernova sequence occurs in several rapid stages. Core collapse. Without enough fusion pressure, the core succumbs to its gravity, collapsing at an astonishing speed and potentially forming either a neutron star or a black hole, depending on its mass. Shock wave formation. The collapse generates a shock wave that spreads outward, heating the star's outer layers and triggering a dazzling explosion of light and energy. Ejection of outer layers. The star's outer layers are expelled into space, enriching the surrounding interstellar medium with heavy elements. These expelled materials contribute to the formation of new stars and planetary systems, continuing the cycle of stellar creation. Betelgeuse's impact on its galactic environment is profound. The explosion of a massive star like Betelgeuse has significant consequences for its cosmic surroundings. The material ejected during a supernova can stimulate the formation of new stars and planetary systems. The shock waves from the explosion may cause nearby molecular clouds to collapse, leading to the birth of new stars. Additionally, the heavy elements created in Betelgeuse's core and released during the supernova play a vital role in enriching the universe's chemical composition. These elements are essential for forming planets and enabling the emergence of life. Thus, Betelgeuse's life cycle plays a critical role in shaping the chemical makeup and structure of our galaxy. Since ancient times, Betelgeuse has been a prominent feature in the night sky, influencing numerous cultures and astronomical studies. Early civilizations recorded and observed celestial bodies, including Betelgeuse, which stood out due to its distinctive color and brightness. In ancient Europe, Betelgeuse was linked to various myths and deities. Its reddish hue and position within the constellation made it a key point of reference in the sky. The star's visibility and fluctuations in brightness were often interpreted as omens or signs by different cultures. Betelgeuse has become a focal point for astronomers due to its unusual behavior and the possibility of a supernova. Advances in observational technology, such as space-based telescopes and high-resolution imaging, have enabled scientists to study Betelgeuse with unprecedented accuracy. Researchers use various techniques, like photometry to track brightness variations and spectroscopy to analyze the star's chemical composition, to gain a clearer understanding of its current state and predict its future evolution. Predicting the exact timing of a supernova is challenging. While scientists can estimate the likelihood of a supernova based on a star's age and characteristics, precise predictions remain elusive. Numerous factors, such as the star's mass, composition, and surrounding environment, influence the timing and nature of the explosion. While current models of stellar evolution and supernova mechanisms provide valuable insights, much is still unknown about the specific conditions that trigger a supernova. Ongoing studies of Betelgeuse and other massive stars are crucial for refining these models and advancing our understanding of these cosmic phenomena. Studying Betelgeuse offers essential insights into stellar evolution. By examining its behavior and attributes, astronomers gain a deeper understanding of the life cycles of other massive stars and the processes that lead to a supernova. Betelgeuse's remarkable characteristics, including its size, brightness, and erratic behavior, provide valuable data for testing theoretical models of stellar evolution. Furthermore, understanding Betelgeuse's dynamics helps astronomers contextualize broader star formation processes and galactic development. The star's interactions with its environment and its eventual supernova will contribute to the ongoing cycles of stellar evolution, shaping the formation of new stars and planetary systems. Betelgeuse's dramatic behavior has captured the public's imagination, fueling widespread interest in astronomy. Educational initiatives and popular science outlets frequently feature Betelgeuse as an intriguing example of the dynamic forces at play in the universe. Engaging the public with these topics sparks a deeper interest in science and enhances our understanding of cosmic phenomena. As technology continues to advance, future observations of Betelgeuse will provide even more detailed information about its behavior and evolution. New telescopes and advanced observational techniques will allow scientists to track the star's activity more accurately, offering new clues about its impending supernova. Researchers are also using computational models and simulations to improve our understanding of the processes occurring within Betelgeuse and other massive stars. These models will assist in predicting Betelgeuse's future behavior and refining our understanding of the forces that drive supernovae. The study of Betelgeuse provides a fascinating window into the life cycle of massive stars and their profound impact on the cosmos. From its vast size and intricate fusion processes to its potential role as a supernova candidate, Betelgeuse remains a key subject in cosmology. As we continue to study this extraordinary star, we gain vital insights into the dynamic forces that shape our universe. Its eventual explosion will not only be an awe-inspiring event but will also contribute to the ongoing processes of star formation and chemical evolution in our galaxy.